Hello friends, today we are going to start one lecture session on physics. The question belongs to AIIMS 2016 and it's a physics question. The question says that we have to find the acceleration. Okay, I'll I'll draw the diagram. See what kind of question is this. This is the rigid surface, rigid wall is there, and the wall is like this. This point, from this point there is a string going. This mass is here, this is small m, and then this mass is attached with this string, and there is a force applying here which is F, right? And this is B, this point is B, and this is C, and this is capital A. These points are A, B and C. The question is that if there is a force, this is the center of the pulley. Okay, this is the center of the pulley, and there is capital F is applying. Then the question is, what is the acceleration of this block? Okay, so as we know, it's the question belongs to Newton's law actually, and we have to draw the FBD. So we see that this is the block which is small m. So as this, there will be F directing towards the right side, so there will be tendency like this m will be going right side because there is a tension force here. So we'll draw the FBD of this. There is a tension force applying right side, because if I'll cut this wire, what will happen? This mass is not going to move right side, so obviously this string is pulling the mass to the right side, and we have no friction here. This friction force is 0. Okay, there is a mg force downward and there is a normal force upward. As we know that according to the Newton's third law, according to the Newton's second law actually, sum of F in x equals to mass into acceleration. Okay, as the body is not moving in this vertical direction, so we can also write, we'll write here the sum of Fy equals to mass into acceleration. So sum of Fy means we'll write n minus mg, this is the net force, which is equals to acceleration 0, because this body is not moving in this vertical direction, so we can easily write n equals to mg. Okay, so this is the first equation, which is, I guess it will be not heavily used because friction is not here. So I will concentrate in the x domain. The sum of Fx equals to mass into acceleration. Okay, so you see here like this tension force is working right side, so we can write easily that in x direction tension force is only there working, so T is equal to m into A. Okay, so we can see here this, there is a tension force here also. Okay, there is a concept that if the pulley has mass, some masses, like suppose m1, if the pulley has mass, then what will happen? The tension across the pulley will change. As this mass does not have, as this pulley does not have any kind of mass, so the tension will be equal across this, right? So as we can see that this F is acting along this pulley, so we can write for this pulley F minus 2t, because you see that in x direction this F is there, and this in negative x, this t plus t, total is t, 2t is equal to mass into acceleration. So suppose we'll take mass into acceleration, and it is said light pulley, so we'll consider m as negligible. So we can say, we can write here, see this one is F equals to ma. So if m is light, what will happen? This is considered to be 0, it will become 2t, so 2 into t, and we'll put the value of t here, which is